Can I put my arm in and have it grab me?
Yeah. No.
Oh, that's awesome!
Right.
Hey everybody, Adam Savage alongside engineer and effects artisan Mark Setrakian. How are you, my friend?
I'm good, Adam.
It's funny, we just did a video about a giant glove, and here we have a giant, beautiful hand. This is from Hellboy. What is it?
This is from Hellboy II, the Golden Army, and this is the iron fist of Mr. Wink, who is the main villain henchman in the movie.
I love Mr. Wink. He's such a beautiful, beautiful character, and when he it's just his, yeah. I don't want to get too far into what he can do because we're gonna.
So Mr. Wink was played by Brian Steele, the amazing, the Man of Steel, Brian Steele, who had to carry in its full hero version. The suit was well over 110 pounds, and a good portion of that was this hero hand. This was one of those things where there was this original character design, and then the drawing started coming through, and then Mario Torres, one of the sculptors, did like a little study, a little clay study.
What the hand would look like.
Right, in this sort of fish shape. And the idea was that we really wanted it to be like a sphere, like the sphere that would open up into a hand.
So that when his fist was clenched, it created a perfect...
Almost like a morning star,
right?
Which it didn't ultimately do, but that little clay sculpture was the basis for the mechanical design, which I did in, I think, something like Ashlar Vellum or something like that.
Just whatever software was available back
then. It has a lot of entirely functional mechanical elements. So there are these little gear hinges here where there's like this little kneecap at each knuckle that moves back and forth in this way. Each finger is a different finger. They're not.
Oh, so you didn't make one finger 4 times. They're all unique.
No, they're each unique. And here it is all opened up, right? And it's obviously it's a version of Hellboy's hand, right? It's like a bizarro Hellboy.
You're right. I hadn't considered that it had a symmetry to the right-handed Doom, but it totally does.
Yeah, it totally does. So and there's some interesting things like the missing the.
I was curious about the
here.
Missing rivets.
Right, rivets missing. This one has 6 facets. This one has 5 facets. There's like all these little details that don't come easily when you're using CAD software. You have to like model everything separately. And the other thing that I think is notable about this is that these pieces are 3D printed. And these are actually printed on, in 2003, these were printed on a Stratasys Titan.
That is really early days of 3D printing.
Yes, it was very early days. I had access to this machine. I used the stuff out of it. And what you're seeing, like this surface, I did all of that with a Dremel after the fact.
Oh, okay, got it. Right? You didn't model it into
No, there was no way of doing that. So I took the parts and then hand textured each one.
Wow.
First with a file and then with a Dremel to give it that metallic kind of pitted, like a rusty texture.
Were they then cast?
No.
Or these are the actual?
These are the actual
parts.
The prints. Yeah, and you can see like there's a line right there where this whole thing comes apart. Like you can take some screws out and you can physically disassemble this, and the servo for this joint is inside that joint right there.
Amazing.
And then there's a servo here, so there's like you can hear it. There's one there, and then another one up there. So this whole area here, I did not model that. This was sculpted. So Mario sculpted this.
Just coordinating those different things is a bear.
Yes. So then there's this piece, which was actually milled in foam from my solid model.
Yeah.
Which was then, then this part of it was sculpted in clay. This part was, I don't remember if we made this piece and then sculpted in clay on top of it, but this is a clay sculpture. So, and this back dome was milled from foam, so it is perfectly spherical.
Right.
But then, sculpted as well, and it's made of fiberglass. So there's like every department, works on this thing.
This has to be one of the earliest films to use 3D printing in a practical prop on set. I mean,
maybe. Yeah. And the cool thing is it still works.
What? Oh my God, that's beautiful.
So it's noisy.
Yeah,
I mean, you can.
That's fine.
Like these, well, not on movie sets.
Sure.
This is not popular. Not popular with the sound department. But this thing is, it's got some authority. It's a little rickety, but you can hear the servos working.
Can I put my arm in and have it grab me?
Yeah. No.
Oh, that's awesome!
All right. Remember, there's gears. It might pinch.
Yeah,
a bit.
no, I did.
And then the other thing that's kind of great about it is if I can get this to work. There we go. Oh, whoa! So there's this chain winder thing here. So the chain winder, which is gonna go back and forth.
Oh yeah.
This is the other part of the design, and see, it's just like loading up in there.
Yeah.
Right, and it can actually.
It's perfectly working. It's a real. Oh God, that's so freaking cool.
Yeah, and it does this in the movie. There's scenes.
Well, I
in the
remember,
film.
but I kind of assumed it didn't work practically. I'll
there it
feed
goes.
you.
No,
in
let
there.
me shut it down.
Yep.
There we go. We can just talk about it. No, quiet.
Oh my gosh.
So yeah. So this part, the funny thing about this part of it is, if I can find my. Oh, there we go. I knew there had to be a mechanism for winding the chain.
Right. That's an
there
actual
wasn't.
thing that people have built and used.
An actual thing.
Yeah.
Well, that would function practically in the part.
Right.
But in the drawings, there was just a hole with the chain going in.
So the art director hadn't
No, there was no direction for what to
figured
do
out
here.
how it would go.
But the problem with that is that I had to make something.
yes,
and,
totally.
and there was no room to like hide it behind a thing. So I decided just to make the most badass looking chain nozzle I could. And so I designed that, and
Achievement unlocked. These bevel gears, 8 bevel gears on all 4 sides are beautiful.
And then there's one additional bevel gear. So that's a DeWalt drill motor with another bevel gear on it.
Oh my gosh.
That engages one of those bevel gears and then spins the entire assembly. And then all the chain will just reside inside this, and there's a handle there for me to hold, and the whole thing just, sucks up the chain like that, and it just kind of piles up inside this thing. So
I love that this still works
Me
20
too.
plus years later.
me too. Yeah.
Oh man. So when
so-
this thing is crawling, that was
right.
practical.
Well,
yeah,
the actual
yeah.
running, I think,
Yeah.
was digital, and I was so close to doing it practically. I was so close, but I didn't have my control system in those days. It was just like all all done all with these.
And when
now
you
that's
use-
not actually that's not entirely true.
Okay.
The early days of my control system were tied into Futaba radios, so I had a thing that would take MIDI and turn it into an analog voltage. So I had from my laptop into this MIDI thing an analog voltage, and I would plug that into the Futabas, and I would have like 2 Futabas. And so when you see things like the little guy in Men in Black talking,
Oh yeah.
right? That's actually wireless, and
right.
that's actually coming from my computer going through Futabas going into that RC head. And the first time I used that was on the first Hellboy, and it was for Cronin's hand, which I didn't even make. It was DDT made this amazing hand.
Yeah.
They were having trouble. I don't have trouble with it, but I basically connected my control system to it, and I had this Wacom tablet, and you'd like just do gestures on the tablet, and the hand would do all this weird stuff.
Oh my
so
God.
When you
That
picks up-
mechanical hand that
when he
Cronin's
picks up his
repairing.
hand and
Yeah.
he docks it back onto his wrist again, that's DDT's hand. And then I'm like in the back with a Wacom tablet, and it's going like this. And Guillermo's like, perfect, cut. I said, okay. Guess he liked it. But back to this.
That had to have been the absolute bleeding edge of what you could do with a Futaba radio at that time.
Sure, but there was a lot of motivation. Like we
Right,
were
yeah.
hacking the stuff out of all that stuff.
Yeah.
And this was something where there just wasn't time. But anyway, to get back to the story,
Yeah.
So the hand's running along, and then we cut to a shot of the hand. It closes up into a fist, drags along the floor. You see Wink. He's like guiding it along. It comes up, lifts off the ground, docks with his arm. He picks it up. The fingers start moving around, and we got that entire shot in camera. And Guillermo even was like looking at me like, haha, Setrakian. They're going to say it was CGI, right?
Right, yeah.
My Guillermo imitation is very rusty, very, very rusty. But,
I'm curious about the chain grabbing mechanism.
Yeah.
Did you find documentation for this kind of mechanism? No.
Oh, I just made this up.
Wow.
And I can show you, if I can leave frame for a moment,
Please.
I'm gonna show you some prototype stuff.
Oh, I'd love that.
That led to this, because I've been doing some digging since you had some interest in this. Let's see what I've got in my scrap box here.
Oh, I love scrap box parts.
So this is an early iteration of one of the chain cogs, and that's one of the original prints. That is
Right.
polycarbonate material, and you can feel how light it is.
I really can.
Right, so it's hollow. This is a typical sparse infill. It's very hard, so it has that. Let's see if it rings.
Yeah, there's a little bit. Yeah.
Right. So like a little bit porcelain-like. So the reason why this is a reject. Here's a more recent print. Is do you see the arc? This arch right here?
Yeah, that hump.
Yeah, that hump. So that was the thing that I needed
Oh.
to get the chain to nicely ride over that and glide fluidly through the mechanism.
And there was a significant difference when it was riding on a flat as opposed to over the hump.
There's other things wrong with this too.
Yeah.
Like the distance between these two radii may not be ideal.
Right.
But this was the winner.
Amazing.
So this was an iteration of one. I got one extra chance after designing this.
I love the fact that one part does both directions of chain grabbing.
Yes, it does.
And this gear mesh in the middle is a crazy.
Well, it isn't a gear mesh. It's
Oh,
actually
it's
just
not.
it's just a cool looking thing. So what happens is that thing sort of wants to go between the link,
Right,
which
just
has
like-
a tendency to kind of pre-center that as it's going along. So watch what's happening. It's alternating, right? It's like over, under, over, under, over, under, and it's grabbing each link.
Yeah.
And it's
That's insane.
and it has a tendency to tolerate if there's some twist in the chain.
right.
Up to a point.
Yes.
Right. Yeah, and then right here, there's a little bit of bungee cord. So when it gets to the top, it's like a shock absorber.
so
it
it's
has
not-
some give when it
Nice.
gets to the top, and it doesn't just pull too hard.
That's institutional knowledge, I'll bet.
It seemed the proper way.
Yeah.
And then this is an
this is
an
the
early
housing
version
for
of the
the-
interior.
gotcha.
Right. So you can see how they go in there exactly like that. So and then you have to pay attention to the teeth. But what you'll notice that I did is here, this tooth is perfectly lined up to this flat. But if you spin it around, the trough is lined up, which means that as we alternate these,
They will still line
They
up.
will still line up. So I have one part that works for, how does this go together? I don't know how I did this together. Anyway, there we go, like that.
Right.
So we have one part that will work no matter which station
amazing.
it occupies. So this is a earlier version of basically the interior of this housing. Many of these files were lost.
Fair.
So I am determined to recreate this.
Oh, good.
And I'm gonna actually disassemble this, and we're gonna scan. We've already done some scanning on it, and we're gonna scan a little bit more of it. And I'm just gonna redo what I did before, especially like that piece, which is the you can see these basically cover the gears, and this is the area where the motor mates up with this thing. So none of that exists anymore. So I'm gonna have to redo all of that.
Wow.
But that's fine.
It is so beautiful.
And
I love how insanely practical it is. And also, like, within the intense mechanical complexity, that there's still an aestheticization of all of this that feels like it's weirdly ancient and modern at the same time.
Yes.
Like some super geniuses we never heard about in Italy put this together 500 years ago.
That was the aesthetic of the film,
Yeah.
like these fantasy elf characters who had been with us for thousands of years and were like attuned with nature, but also had their own level of technology. And this was that. So no, I love it. I love the way it looks. I love the way it feels.
Must make you feel connected to Nuada and his folks.
Yeah, I think you got a pretty raw deal.
I totally agree.
But let's talk for a moment about how all this is made. So I try to always have a level of simplicity in my work. So that servo probably needs to be replaced.
Sure.
Yeah, just from the sound of it. There are two really thin aluminum plates here, and that comprises the entire structure of this. So if we look at the root of one of these fingers, like let's say this is the thumb.
Oh, wow.
So this gets captured between those two plates, like so.
Yeah.
And the orientation of the thumb is built into the part. So the fact that it's not flat, it's not straight.
Ah, yes, right.
It's at some weird angle. This is where the servo screws on. See where the little screws go. So that would be that servo down there, pushing on that.
And so you spent a lot of time over the last 20 years making 3D printed servo mounts, but this is the first one. or give or take.
Give or take, yeah, maybe
Yeah.
so, yeah.
And because this is so custom, and you said the fingers aren't the same, every single part from the base of each finger and each of the metacarpals are different, slightly different.
Maybe this part here is the same for each of them. It's possible this part is the same for each of them, but as I'm looking at it, I can tell that they're not. Like this one has this aggressive radius on it, and this one doesn't. So maybe these three are the same, and this one is unique.
When you're first conceptualizing a design this complex,
Yeah.
do you start in CAD or on paper, or do you start in your head?
Almost always in my head and on paper.
Yeah.
And sometimes I'll do some exploratory CAD stuff, but I don't find CAD to be a very generous medium for inventing ideas.
Right.
I always go back to paper at some point or another.
And in paper, are you drawing like orthogonal drawings or elevations, or are you just trying to break it down into its chunks to solve each problem?
What I do is I draw the same thing over and over again from different angles.
Yeah.
So in perspective, and from the top, from the bottom, from the front, and then I just keep doing that until I start to feel that I've cracked whatever the
You start to understand where you could run into trouble.
spatially.
Right,
yeah.
right.
Because the thing you always run into when you're trying to make something like this is you're packing a bunch of stuff into a very tight space. That's robotics. Robotics is highly integrated systems.
Yeah.
So there's always this fight for space and this fight for weight, and where is the weight, and how is the space being utilized?
And how is the weight going to change how it operates?
Exactly. So like having a servo here, that's okay. In here, great. Up in here, no, that's going to be a problem. Right? You don't want to swing. You don't want to swing that weight around. Right. These fingers should have a kind of effortlessness to them. So where you put the weight will influence that.
And can I assume that knowing not to put too much weight out at the ends of the fingers was a lesson you learned the hard way?
Well, some of those lessons are hard, and some of them are you start to do it, and it's instantly obvious that it's the wrong thing to do. Right? You don't have to make it to the point
that
where
you want all your heavy mechanicals at the base of the thing.
Right.
Dude.
Yeah, but imagine all the hand I'm looking at. It's like, wow, I hand finished all this stuff. And I made 2 of these.
You made 2 of them?
Yes, there was one which didn't have the chain mechanism. So it was just a hand without all this extra stuff.
Right.
Because there's no sense in forcing poor Brian to carry around like an extra 5 pounds of chain and motors.
Fair. Fair.
I love these joints. I love the way that like creates this unbroken surface. Well, it's not unbroken, but it becomes like a sort of architectural feature.
And is the servo actually turning on to that gear, or is it meshing with that gear, and that's how that's operating?
Yeah, it is. In fact, these gears here, those are cosmetic.
Right.
That's a functional gear.
But what I'm getting at is that this gear makes these turn, but that gear and these gears are not on any common radii.
Well, if you think about this as like a pair of like this axis is being twisted around like that.
Right.
And so this is going to be forced to find the middle of those two things. So this distance doesn't change. But as you drive this, you're basically swinging this thing back and forth on this axis. So the servo is driving this gear, which is part of this axis. And this joint is then doubling the angle through this joint. So without this here, this is going back and forth 45 degrees. Then you add this thing, and now this thing's going back and forth 90 degrees. And it's also pivoting at a different point in space, which makes it visually confusing, right? Which is interesting.
It adds mechanical complexity, and I start to think this is really mysterious and weird and awesome.
Exactly. Yeah, I love that. I love having two things. I love having a surprise. So like the chain thing, it's like a surprise, and the fact that there's this weird mechanism that's like disgorging this chain like a spinneret, like a spider spinneret. And then the added okay, it could just be a joint here at each knuckle. But it's not only more visually interesting to have this gear hinge here, but I can actually bend this thing to a much tighter radius because this is acting like a knee, like a kneecap. So it's allowing this to fold over.
I'll go one further with you. It turns out that some raptors actually have ratcheting tendons in their claws, so that when they grab prey, they literally cannot let go. Until they've eaten the prey out of their hand. And this, when I first saw this, I was like, once he gets you, he can't let go of you. You're done.
Well, there's lots of things you could do, what opportunities are there with the surface of this, with the surface of that, to like have this come in and become a very powerful gripping force?
Yeah. Do you find mechanical arrangements out in the world that you admire or get excited about and come back and diagram them and think about them for future stuff?
I do sometimes, and now with the advent of scanning apps, you can just like when you see something really cool, you can just like do a little scan of it and sort of refer to it later. But oftentimes I find that what I think I see and the inspiration I derive from that is totally wrong. And I get inspired and make this interesting thing and then find out that the thing that I saw, it didn't do that at all.
It didn't work that way.
That's not at all the way it works.
You just reinvented something totally different.
Right, or yes, yeah, that happens a lot. So it's even better in some ways.
Dude, I will tell you that I'm always feel a little more illuminated about how the mechanical world works when we hang out together. I really appreciate you taking me on a deep dive through this guy. He's so beautiful.
Thank you, Adam. I appreciate that.
Amazing.
Alrighty.
All right. See you guys next time.
Thank you guys so much for watching. I'm going to tell you about some brand new merch we have. One of my favorite things we've ever produced are our demerit badges, which are scout badges for messing things up, as we all do. They're bestsellers, and we started out selling them as patches, then we moved to stickers, and now, ladies and gentlemen, we have demerit badge magnets for your fridge or your machines, and we started out with a 4-pack of our greatest hits. You can find these right now at tested-store.com.